This video will cover the topic, finding the roots of a quadratic equation of the form ax squared plus bx is equal to 0.
What do you mean when you say roots?
A root is a value of x which makes an expression equal to 0. So really, we're looking for solutions to the equation ax squared plus bx is equal to 0. Roots are also called x-intercepts, and if we were to graph this function, the roots would be where the graph crosses the x-axis, as shown in the example on the screen.
I think I remember something. Doesn't anything multiplied by 0 equal 0?
That's right! Any number multiplied by 0 will equal 0.
Well, since there's an x in both terms in this quadratic, can we just make x equal to 0?
We can! A and b are numbers, so if we set x equal to 0, then a times 0 squared plus b times 0 is equal to 0, which simplifies down to 0 is equal to 0, which means that x is equal to 0 is one of our roots.
Wow, we didn't even have to figure out what a and b were to find that. So, is that all we have to do?
Not quite. Since this is a quadratic, there can be two solutions. We've found one of them, but to find the other, we'll have to factor out an x from our original equation. Our equation now reads x times ax plus b is equal to 0. The x by itself just means that 0 is a possible solution, but to find the other one, we're going to have to be given values for a and b. Let's go ahead and try an example. In this example, we're being asked to find the roots of the equation 5w squared plus 15w is equal to 0.
Hold up. This equation doesn't have any x's in it. Is it still okay to use the method we just learned to solve for the roots?
That's a great observation. Yes, we still can use the method we just learned to solve for the roots. The w in this equation is the variable that we will be attempting to solve for, much like the x in our last example.
Okay, that makes sense. Well, don't we know that one of the roots is w is equal to 0?
That's right. With expressions of the form ax squared plus bx is equal to 0, x is equal to 0 is always going to be a root. So we know right off the bat that w is equal to 0 is one of our solutions.
Okay, so now we factor out a w, right?
Exactly. When we do this, we're left with w times 5w plus 15 is equal to 0. Now that we have our equation in this form, we can ignore the w on the outside of the parentheses because we know that it just means w is equal to 0 is a root. Instead, we can focus on solving 5w plus 15 is equal to 0.
I got this. We need to get w by itself, so we subtract 15 from both sides and then divide both sides by 5, right?
That's right. When we do this, we're left with w is equal to negative 3.
Okay, so are the two roots w equals 0 and w equals negative 3 then?
You got it.
Okay, I think I get it now. When we have a quadratic equation in the form ax squared plus bx equals 0, then we know that x equals 0 is always a root. But to solve for the second root, we need to factor out an x and solve for the remaining root by setting the equation inside the parentheses equal to 0 and solving for the second root.
Great job. It really sounds like you have it down.